Hi, Binary Viking here, and I'm back with another tutorial on C#. And last episode I promised to go over some of the symbol and sign we have around here. And the first one is this semicolon. And if you never have programmed before, you probably would not uh, would not know what it's about or what it's used for, but pretty much it is an indicator to say the line ends right here. It's kind of like a dot in a novel or whatever you write, normally school paper. So it's pretty much to say the line stops right here. We can even do like this and the program will still recognize everything because we can see in the error list there's no errors. But if I was to delete one of these, let's say like this, we instantly get an exception that we need one. So pretty much what it is a way to tell the program or compiler that here in this line of code, other programs or programming language does not use this sort of symbol to indicate here in the line. Some other actually does not use any of these at all and have begin and end, for instance, or just new line like you would normally see if you clicked enter. So the next thing is these right here, the brackets, or curly brackets I actually think they're called to be exact. What these indicates is the body of, let's say, the class here. The class here is of course a class. I will go more into classes later on, but for now we have a class program and we inside the class have a body, which is all this. The body contains of methods or functions. In this case in C#, it's mostly referred as methods. And this right here is a method, which is called main. And inside main, we again declare a body. Everything in the body is everything we typed in here in the last episode. The last thing you may notice is the namespace, which is the most outer body. To be honest, you can decide to delete it just like this and not have any namespaces, but in most cases when you program, it's recommended to do it. A namespace is pretty much a place where you have your code, or is designed to have your code. Just like we have up here, we are saying using system. System is a namespace that we are using in this. And actually we can't delete these because they are not used right now. But for instance, if I was to say using, we can actually see that tutorials should be in here. So it's pretty much like a package that we can use other places. We can say that we want to give some other developer or another person our code as a binary file, and they can then add it to this solution, and they can pretty much just say using and tutorial 1 in this case, as we have it right here, and semicolon of course. So why is this smart? Well, first of all, it's smart because you can do something like saying, okay, I want another namespace below. We can call it tutorial underscore 2, for instance. And we can then inside here define new stuff we want to use, and up here say I want to use tutorial 2 namespace. So it's a way to arrange your code logically so other or yourself can find it more easily. Next thing is the static. Static, well, it's kinda something I do believe I want to go over later. Yes, I want to go over it later. There's a good place to go over it later. So we have void, which is a keyword or type, kinda, just like string. Void is a way to say it returns nothing. In a method we usually have, well, in this case we must have static because main must always be a static method. But that's not important right now. Just remember the main method must always be static in C#. We then have here the return type, and the return type is what the method should return. In this case, when it's void, it will not return anything. We could, for instance, say we wanted to return a string. This would be legal to do, and then it will return a string to us for us to use. But the main method must always be a static void in C#. In other languages such as C or C++, it's actually a int main, which is another type, and we here have the parameters. And parameters is another thing I will go over in the next episode, probably, how to use, and also a bit more about return types. And the same in here in the body. Everything inside these parentheses, sorry if I didn't say that correct, but you get the point, is also parameters. In some cases you can have more parameters, and normally you will use a comma to have a new new parameter. In this case you can see it's an object, and you can inside in Visual Studio, I do also believe you can in Mono Development, go through all the different types of parameters or what types of parameters these method takes. You can see the one we're using right now is this one, and it's usually getting bold type, or the font getting bold when you use a certain one. But we can go through and see, okay, we could use an object, we could use a long, which is all different types we can have in here. We can even use a char array and so on. So now where we have talked a bit about how this works and everything, let's talk a bit about types. So C# is a strong type language, if I'm correct. And what this means is we have types like this. So for instance, if I was to make a new string up here, string, let's just call it test string, and I would say it's equal a number like this, it would be completely illegal to do this. We can also see down here we cannot convert int to string. So what we have over here is right now an integer or an int. So if I do this, it would suddenly be completely legal and there would be no problem. We can do another thing, and that is using var, which some may know if they have ever programmed JavaScript, I think. But usually I do not recommend doing this in C#, and the reason being is, first of all, you have the types, so you might as well use them. And personally, I do not really like that you have you can use var to hold some sort of variable. The reason being is this way you always know what is inside this string, or well, not test string, actually it's test int now, of course. Sorry about that. So we always know that this is an int, and we cannot be like it's a var and suddenly it's not an int, because now it's actually a string and it's still okay, it's no problem. So yeah, always try as much as possible to use the types. Another thing you may find interesting is how you can convert different types. So let's say we have a test string here. We can actually say the test string should be equal test int. Just oh yeah, right. So we can convert it, we just need to put in a string here, if I recall correct. Oh, sorry, not like that. We need to do like this to string. Sorry about the confusing there. And now it will simply change the int to a string, and it will lie inside this variable right here. If I set up a breakpoint, and you can possibly do that in Mono 2. As I said, I'm not so familiar with Mono development, but if we do like this and we hover over, we can see that this is right now a string, and the string always have the quotes besides it, the double quotes, where int will not have the double quotes, as we can see here. There is of course a lot of other types, and we can even make our own types, and I will go more into that in another episode, where we actually are going to talk a lot about classes and how we can make our own types and objects and all. But for now, you have something to go around with. We also have, for instance, uint, and we have long, we have short, we have a lot of different keywords, and the main thing about it is how long they are. For instance, a string can hold characters, I think almost any length of characters. I think they can hold up to, I think it's 4 gigabytes of data in a string. I may be wrong, but I think that is the maximum it can hold. You can, in a int, have 32 bits, and that is roughly equal to something like 2 billion and 100,000 million something. We can actually go ahead and print out how much it is. For instance, if we do console dot write line, we can actually print out int dot max value, for instance, and that works for almost every single type. We can even do it with uint and say max value. Let's do it for int first, for instance, just because why not. If we compile now, we should see right here, that's the maximum or highest value an int can hold. It's a 32-bit, and for uint, which is a 64-bit, you can suddenly see it's, oh sorry, it's not, it's still a 32-bit, but the U means it's unsigned, so it can not be minus. Sorry. The one I'm talking about is the long, which is a 64-bit, and we can suddenly see how big the number is. And we can even make it bigger if we say ulong, which again is an unsigned value. And everything that is unsigned means they can't go in minus. So if we ever was to assign a negative value to a uint like this, UI for instance, if we said -1, we would simply get an error because it can, well, it says here it can't be converted, but pretty much because it's a minus, it can't. That's why it can't be converted. So it always needs to be positive if it needs to be unsigned. Alternatively, you must use int or a long or whatever else, and you can then easily use minus or whatever. Another one is byte, which I didn't talk about. We have sbyte as well, which is a signed byte. And as I said, the difference between unsigned and signed is signed can hold positive and negative values, where unsigned can only hold positive values. You can go to Google, I will try to do it fast here, and say C# types. If we go in here, we can see different types here. And in this graph right here, we see how we can cast them. We also have in here how big the difference is. That's actually a pretty good one right here. So this is the different types. We have Boolean, true or false, byte, so on, all the way down. And you can possibly find these other places. We have a char. Also, char is a different or special type. The way it works is it holds one character, and you can pretty much see a string as a stream or more than one character. So yeah, that's pretty much it. I think I will end the episode or tutorial here. I already gone over time, so thank you very much for watching. Take care until I get the next video up. Bye.